So next in lesson 2.4 of the 7th grade textbook, students are expected to work on some word problems, some application problems. This might be kind of hard to read. It is number 17, and again, it's in lesson 2.4 of their extra practice worksheet. It says Cecilia has an 8-inch by 12-inch sheet of rectangular paper. Easy for me to say. She cuts out identical 4-inch by 3-inch rectangles from two corners of the paper. Well, let's see. 4-inch by 3-inch rectangles. I see those here. It says, she then cuts out identical right triangles from the other two corners of the paper. Oh, there are the right triangles they're talking about. Using the diagram shown, find the area of the remaining paper. So first of all, they gave me kind of a hint here. They told me that these rectangles are 4 by 3. They didn't label this piece for me, did they? And this makes sense. 3 plus 2 plus 3 gets me a whole side length of 8. That's what I want because it's opposite that length of 8 inches. These triangles could be trickier. I'm going to have to think about this length compared to this length. Oh, if you notice, this hits the halfway mark, right? And I know that because of these little marks in geometry are telling me that I have some congruency happening here. So this half is the same as the other half. These both must be 4 inches. 4 inches. So I'm just kind of labeling pieces. I want to find the remaining paper. Oh, that means that something's going to be left over. That really means that I'm talking about subtraction. Well, to start, it probably would be helpful to know how big this paper was from the get-go. So, do I know the base? Sure do. Looks like it's 12 inches. Do we see a height somewhere? Oh, right here, the height. So I could start with a base times a height. Next, I'm going to start taking things away. I'm going to start cutting off some pieces. So I'm going to take away some rectangles. How many rectangles are we taking away? Looks like I'm taking away 2 of them. And what was the area of the rectangles? Oh, that's right. I want to think area equals base times height. So this is kind of just kind of in the back of my memory here. So the area of this rectangle would be base times height, 4 times 3. And I'm taking away 2 of them. That's why I have this 2 out front of the parentheses. It's showing 2 groups of 4 times 3. But I'm not done yet. You're taking more away. If you look, they cut out 2 triangles as well. So I'm taking away a little bit more. And I said I was going to take away 2 of them, not just 1 triangle, but 2. Oh, this is a different matter. This is area of a triangle. And the formula for that, if I remember, is 1/2 base times height. Or sometimes elementary teachers call it base times height over 2. You can see Mrs. Kalinowski just scared me with her door. All right. So next to this, I want to show you what the base times height over 2 would look like. So I might write in parentheses, well, the base is 4, the height is 4, 4 times 4 all over 2. All right, I think I'm ready to simplify. If I can start with the original area, take away the rectangles, take away the triangles, I should have what's remaining. So it's time to start simplifying. To start with, I noticed parentheses, and if you remember PEMDAS, that means I need to look at parentheses first. So could I simplify right here, 4 times 3? Yep, I'd get 12. I'm going to keep that in parentheses for a minute because I notice this 2 is sitting out front. That's pretty important, pretty critical. All right, I'll bring down everything out front that I haven't used yet. Is there anything over here that I can simplify? Well, I need to bring down that -2. And in this parenthesis, I need to take care of numerators first. What's 4 times 4? 16. 16. And it's still divided by 2. There's still 16 over 2. I'm getting a little bit closer. It looks like I have a couple operations left. If you notice, there's something sitting right here in between each of these that it's hard to see unless you think of it algebraically, I think. This is actually a demonstration of multiplication. There's actually multiplication here, and some people might want to actually draw that in just so that you're getting a right operation. But is there something before that multiplication that I should look at? Is there anything else in parentheses we could do? That's just a number being housed in parentheses. There's nothing to do with it. Here's another integer in parentheses. That's as much as we can do. And how about back here? 16 halves. Could that be simplified? Oh yeah, it could. So I'm going to copy down these pieces that I can't work with quite yet. 2 groups of 16 over 2. Oh, that's the same as 8. Good. Again, this multiplication symbol, you may want to show yourself just so that you remember what to do here. So should I multiply, subtract, or multiply first? Well, in PEMDAS, you would take care of multiplications. And because these are all happening on the same level, I probably could do that all together right now. 8 times 12 is actually 96. 2 times 12 is actually 24. And 2 times 8 is actually 16. Be careful here. If you notice, you still have subtractions happening in between them. If I only have subtraction left, you could say subtraction is a lie. We could change this to add the opposite. And 96 plus a negative 24. Different signs subtract. So let me think. It looks like I would get here 72. Would it be positive or negative? Well, it looks like it'd be positive. There are more positives than negatives, or 96 is farther from 0 than negative 24. So next I need to bring down this plus a negative 16. I'm a little disappointed because I'm running out of space here. This would be a good reason to use lines, or to have less space taken up in here. So next step, 72 plus a negative 16. We'll pretend that this tank problem isn't in here. Well, this is another different sign subtract. So let me think. 72 take away 12 would get me 60, right? But I want to take away 4 more. So 60 take away 4. Sounds to me like I'm going to get 56. Would it be positive or negative here? Different sign subtract, keep the sign of the farther number. Oh, 72 is farther. 56 looks like a good number answer. Why isn't this done yet? Because this is a word problem, and I need to go back and make sure I answer in word form. So use the diagram shown. Find the area of the remaining paper. Oh, this is talking about remaining paper. The remaining paper has an area, remember we were talking about area, of what? Of 56. 56 what? That's kind of embarrassing to leave it looking like that. So we need to think about a label. What am I measuring in? Anywhere I look in this problem, they were using inches. But inches is a linear length, and I'm talking about area, meaning I just took inches times inches in every one of these objects or shapes. So inches times inches gets me inches squared. The remaining paper has an area of 56 inches squared. If you notice, if you do a good job, what you end up with? Pizza, or yes, an inverted triangle. Some people call these cones.